All right, in 3.4b, we're going to look at probability with a different method using what we call Venn diagrams. Two-way tables can be used to illustrate the sample space of a chance process using two events. So can Venn diagrams. A Venn diagram consists of one or more circles surrounded by a rectangle. Each circle represents an event. The region inside the rectangle represents the sample space of the chance process. In the previous examples, our events of interest were A is male and B has a pierced ear. Well, here's the two-way table that summarizes that data, the same table we used before. But now, look at the Venn diagram that we've created. Okay? The intersection of two circles means that they're male and they have pierced ears, and that's where that 19 came from right there. Okay? So we intersect, that's where the 19 is. The inside the A circle, which is the yellow one, but outside the B circle is the males with no pierced ears. That's the 71. So don't be fooled. 19 plus 71 gives us the 90. It's just the 90 is not on the diagram, but it's there if you add the two pieces, 71 and 19. All right, so then inside the B circle, but outside the A circle, are the females with the pierced ears. That's 84 there. And then the other four are females but do not have pierced ears, so they fall outside the two circles in the diagram completely. All right? So I'll show you more about how to build your own here in a minute. Some standard vocabulary and notation have been developed to make our work with Venn diagrams a bit easier. The complement of A, like this notation, contains the outcomes that are not in A. So you can see we've shaded the outside of the circle. The event A and B is also known as the intersection of A and B with a corresponding notation. And it's this upside down U, which it looks like an A, and that's how I remember that it's the and. Okay? It's the and. So the and, A and B, is the intersection. So it's just this little piece right here. The event A or B is known as the union. So we use the symbol U for union. That means everything. The corresponding is A union B. So notice it's all of it. In probability, or doesn't mean you have to choose A or B. You could have both. It's kind of like at Starbucks. You could have sugar and half, or both. Okay? Let's try an example. According to the National Center for Health Statistics, in December 2012, 60% of U.S. households had a traditional landline telephone. 89% of households had cell phones, and 51% had both. Suppose we randomly selected a household in December of 2012. What's the probability that the household has a traditional landline or a cell phone? All right, so let's look at this. First, we need to construct our Venn diagram to represent these outcomes. All right? So when you do this, the very first thing you're going to do is look at the intersection. How much is both? Well, it's right here. It's 51% had both. So I'm going to make that 51 a decimal, make it 0.51. It says T is for traditional and C is for cell phone. So here's T and here's C. All right? 51% had both. Now we look again. It says 89% of the cell phones had, or 89% of the households had cell phones. Then it says 60% of U.S. households had a traditional landline telephone. All right? So those pieces of information are going to help us fill in the rest of it. Now, okay, I take that 60 and I'm going to subtract the 51 because I don't want to count it twice. When I subtract it, I get 9 left, and that's 0.09%. And then it says 89% of households had cell phones. Well, I don't want to count that 51 again twice, so I take 89 minus 51, and I get 38. So this is going to be 0.38. All right? Now, all our percentages should add up to 100. If they don't, then what's left is what's on the outside of the two circles. So I have 0.09, 0.51, that gives me 60, plus 38 gives me 98. So there's 2% left out there. So this 2% is out here in the sample space. That means they don't have a cell phone or a traditional landline. Okay? Now, using this information, I can answer this question. What's the probability that the household has a traditional landline or A cell phone. So notation would look like this. Probability, traditional landline, or cell phone. Okay? And remember, the or, when you do Venn diagrams, is all of the stuff in the circles. All three of these. Okay? If we added them up, which we did earlier, we got 0.98. Okay? That's the probability. Now, B says, find the probability the household has cell phone only. So the probability of C, which represents cell phone only, and that would be, if you just read the diagram, it's 0.38 or 38%. All right? Let's try another one. Construct a Venn diagram and answer the following. A survey of couples in a city found the following probability. The probability the husband is employed is 0.85. The wife is employed is 0.6. And that both are employed is 0.55. Feel free to pause the video and try this on your own, and then play it and see if you got it right, just as a way to find out if you got a hang of this. All right? But I would recommend we start with the both part, the intersection. Let's label this. This would be the husband's employed, and this is the wife's employed. Okay? Now, for both to be employed, that probability is 0.55. Probability that the wife is employed is 0.60, but I already have 55% of that in here. So 60 minus 55 gives me 0.05. And then for the husband's, 85%. So that means everything in the husband circle adds up to 85, but I already have 55. That leaves me 30%. Now I see if there's anything outside this sample space. So I have 30 plus 55 plus 5. What is that? 85. That gives me 90. So there's 10% left that's hanging out here. All right? Now that I've done that, let's look at the question. Find the probability that P, at least one of them is employed. Okay, at least one means one or two, right? It means one or two. So it's the union of the two. This is also asked, could be asked like this, husbands and wives. Okay, so that's the union of all three pieces. And we know that that adds up to 0.90. Okay? B says neither is employed. Look at that. The neither is employed is this piece outside both of those circles. So that's just 10%. Easy enough. Venn diagrams are very helpful. You just got to know how to construct them, and then it becomes pretty simple.